Good morning, everyone. I am going to go over section 5 of chapter 9, which is on combinations. So we just talked about permutations. Now we're going to talk about combinations. There is a practice on quizzes for you guys. The code is down below. It's also on Google Classroom, so make sure you are getting that done today. So kind of the opening question, I'm going to move myself because I'm in the way. So it says, Mr. Rios is making a salad for a party. He has tomatoes, green peppers, cucumbers, and radishes. He starts with lettuce and then decides to add 3 of the above ingredients to his salad. Right, so he has lettuce, cucumbers, green peppers, and radishes, and then he's only going to add 3 of them to his salad. So we have 3 questions that go along with this. The first one is asking you to list all the permutations of ingredients using the first letter of the vegetable. So instead of having to write out tomatoes, green peppers, cucumbers, and radishes a bunch of times, we're going to write out the ways in which he can put these vegetables into his salad. So starting with kind of the order that they're already in, I can use tomatoes and then green peppers and cucumbers. Then I could do tomatoes, green peppers, and radishes. I could do tomatoes, cucumbers, and radishes. Then I could move over to green peppers and I could do green peppers, tomatoes, and cucumbers. Then I could do green peppers, tomatoes, and radishes. And I could do green peppers, cucumbers, and radishes. Then I could do cucumbers, tomatoes, and green peppers. Then cucumbers, tomatoes, and radishes. And then finally, cucumber, green pepper, and radishes. Okay. If you want to write them out and do like tomatoes, green peppers, cucumbers, tomatoes, green peppers, radishes, that's up to you if you want to write them out completely and that makes more sense to you to put them in order and organize them a little bit more. So looking at this, the first question asks how many permutations are there? So it would be 9. Then the next question is asking you to cross out any arrangements that contain the same letters as another list. So when you're doing this, if I already have, so looking right here, I have tomatoes, green peppers, radishes, or this is a C, cucumbers. And then right here, I have cucumbers, tomato, green pepper. So it's the same list. They're just in a different order, but because I have this listed already, I'm going to cross this one out. Then right here, I have tomato, cucumber, radish. Over here, I have cucumber, tomato, radish. So I'm going to cross this one out since I already have this listed. Right here, I have tomato, green pepper, radish. And then over here, I have green pepper, tomato, radish. So it's the same letters, just in a different order. So I'm going to cross that one out as well. Looking at this one, I have green pepper, tomato, and cucumber. Up here, I already had tomato, green pepper, and cucumber listed. So the same letters, I'm going to go ahead and cross that one out. Then I have green pepper, cucumber, radish. Over here, I have cucumber, green pepper, radish. So I'm going to cross one of them out. So I'm left with these. I have tomato, green peppers, and cucumbers, tomatoes, cucumbers, and radishes, tomatoes, green peppers, and radishes, and then green pepper, cucumber, and radishes. So these ones all have different letters. So now it's asking how many do you have now? So I have 4 left that kind of don't have the same thing as anything else. So question 3 is asking what is the difference? The difference is what we're talking about and kind of what the title of the lesson is. So number one, you found the permutation. So that was when I did, I had 4 things to choose from, and I'm putting them in order and finding out how many there are. Then for number 2, I have what is called a combination. So that's what we're getting into. So permutations, the order matters. With combinations, it doesn't. So earlier through this chapter, we did the tree diagrams. It's similar to that. That's one way that you can still do this. It would take a little bit more time, but figuring out and crossing out what you have that's already the same. So if I have a blue car with a hard top versus a hard top with a blue car, they're really the same thing, just in a different order. So with combinations, the order doesn't matter. So we're going to start getting into some examples with this. Looking at this first example, and there are kind of 2 ways that you guys can go about solving these problems. Whichever one is easier to you, it doesn't matter. It's just giving you the information for you guys to use. So this first question says, Terrence's Pizza Parlor is offering the special shown in the table. And I know that this is not a table, but the information is all right here. And the question is asking how many different 2-topping pizzas are possible. So this is asking you to find a combination. So it doesn't matter what order they're in. It's just asking you how many are possible. Okay, so it doesn't matter. And if I'm doing pepperoni and sausage and then sausage and pepperoni, that does not count as 2. It's still the same 2 toppings. Okay, so looking at method 1 first, I'm going to use the letter. If you want to write the whole word out, that's up to you. It's just easier to write the letter to kind of save some time. You're going to write the letter of all the toppings of all the options that you have. So again, this is kind of the same thing as the tree diagram. If I'm starting with pepperoni, then I could have sausage off of it, green peppers, onions, and then mushrooms. Just think about it that way. If that's easier for you, make a table. I just listed them right here. So the toppings that I have to choose from are pepperoni, sausage, green peppers, onions, and mushrooms. So I have a total of 5 toppings that I can pick from, and I'm trying to make 2 topping pizzas. So if you look over here, you can see what was listed. So this first column was kind of just starting with pepperoni. So I can choose from pepperoni and sausage, pepperoni and onions, pepperoni and mushrooms, and then pepperoni and green peppers. Then my next column was starting with sausage. So I can do sausage, pepperoni, sausage, onions, sausage, mushrooms, sausage, green peppers, then green peppers, and list the 4, start with onions, list the 4, mushrooms, and then list the 4 other ones. So with this, I now have every possible way listed, and then you're going to cross out the ones that are the same. So what that means is right here, I have pepperoni and sausage, and then I have sausage and pepperoni repeated. So I'm going to cross out one of them since that's really the same thing. If you look at a pizza, it doesn't matter which one's thrown on your pizza first. You still have both of those 2 toppings. Right here, I have green peppers and pepperoni. Down here, I also have pepperoni and green peppers, so I'm going to cross one of them out. Right here, I have onions and pepperoni. I have another one right here. Mushrooms and pepperoni, I already have listed over here. Green pepper and sausage, I already have listed down here, so I'm going to cross this one out. Onion and sausage, I'm going to cross out because I have it right here. Mushroom and sausage, I'm going to cross out because I have it over here. And it's kind of easy to see with the letters. I have O and M and then M and O, so I'm going to cross this out. M, G, mushrooms and green peppers I already have right here, so I'm going to cross that out. Onion and green pepper I have right here, so I'm going to cross one of them out. And I think that is all of them. Green pepper and mushroom. So I now have pepperoni and sausage listed once, onion and pepperoni listed once, mushroom and pepperoni listed once, pepperoni and green pepper listed once, sausage and onion, sausage and mushroom, sausage and green pepper and onion, green pepper and mushroom, and then onion and mushroom. Okay, so everything should be listed one time. So if you now go back and count all of these, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that is your answer. You have 10 possible ways that you can make a pizza out of these 5 toppings. Okay. This second way is a little less time consuming as far as having to list everything out and then go through and double check that you've crossed everything out. I would strongly suggest if you're going to do method 1, make sure you cross it out and you double check yourself, because it's really easy to cross something out or think you crossed something out or miscount. So if you're going to do that, make sure that you do it correctly. So the second method that you can use is finding the number of permutations of the first set. So that's step 1. What that means is I have 5 toppings, and this is what we did with permutations. So I have 5 options. Then in the second slot, I now only have 4 options left for me to choose from. So I have 5 right here and then 4, because I'm only doing a 2-topping pizza. That's the reason I only have 5 times 4, not times 3 times 2 times 1 like we were doing. So there are 20 to choose from, which is actually what you guys listed out over here. You've listed a total of 20. Then your next thing is to find the number of permutations of the smaller set. What that means is I have 2 toppings, okay? The first topping is gonna be one of those. It's gonna be from the 2 choices that you have of the 2 toppings, and then the second one will be 1, which is what you have left. So there are 2 ways that you can arrange 2 toppings. Then you're going to divide the total set by the smaller set. So I had a total of 20 toppings that I can choose from, and only 2 ways that I can do that. So 20 divided by 2 is going to give you 10, which is what you found over here as well. So either way is going to get you the correct answer. Looking at the next example to kind of continue going through this, to give you multiple examples and multiple ways that you can do this and kind of questions that you'll see from this. So the second question says, a one-on-one basketball tournament has 6 players from the regional finals. Each player will play every opponent once. The 2 players with the best records will then play in the championship. How many one-on-one games will be played? Okay. So your goal is to find the number of ways that 2 players can be chosen from a group of 6. Okay. This is using the second method. If you want to use the first method, you can. So looking at the entire set, there are 6 total players. So once I've chosen the first person, I then have 5 people to pick from, and I'm only talking about 2 players since I'm talking about a one-on-one basketball game. So I have 6 times 5. That's the way to choose from the 2 people. So this would be 30. And then again, the bottom set in this case, since I'm choosing 2 players, would be 2 times 1 or 2. So there are 2 ways to arrange those 2 players. And then I'm going to divide like I did in the last example. So I'm taking 30, the entire set, divided by the 2 ways possible to get 15 games. And in this example, it's a little bit different. I have to add 1 to that because I'm now including the final game. So the final game isn't included in that first kind of set. I then have 2 players that will play in the championship game. So my total number would be 16. There is another way to kind of solve a problem like this, which I'm going to show you on the next slide. But if this makes sense to you, stick with this. So you're finding the number of the entire set, dividing by the way to arrange it, and then getting your final answer. So looking at, this is the same exact question, so I'm not going to read it again. But looking at this same question, Another way that you can do this, if I have 6 players, and I'm just gonna put little dots. Okay, so I have a total of 6 players, and this is for those of you that are a little more visual to see this, and I'm gonna use different colors to hopefully help you see this. One way that you can do this is to take the first player or the first dot and connect them to all 5 players and then count the number of lines at the end. So I'm going to show you this really quick. So if this was player 1, he can play with this player. So let's label, I'm going to go around and label him really quick. So I have my 6 players. So the first player can play 1, 2, the first player cannot play himself. The first player can play 2, 3, 4, 5, and 6. Then player 2 can then play player 6, player 5, player 4, and player 3, and he's already played player 1. Then player 3, he's already played player 1 and 2, so he can play 4, 5, and 6. Sorry, I'm trying to find colors that I haven't used yet. Then player 4 has already played 1, 2, and 3, so he can play 4. Sorry, he can play 5 and then 6. And then finally, player 5 can play player 6. Nope. Sorry, guys, it's trying to say that I want to erase. And I do not want to erase. Let's see if it does it this time. Nope. Okay, well, pretend that there is a line between, there we go. So then player 5 can play player 6. Sorry about that. My computer is not wanting to work at the moment. So I now have all of the lines connecting every player. So if I were to go back and count my lines, I have 1, 2, 3, 4, 5 purple lines. For player 2, he played, I guess this line got erased earlier. So he played 4, then player 3 played 3 people, player 4 played 2 people, player 5 played 1 person, and then player 6 is accounted for in all of those. So if I were to add this up, this is 9, 10, 11, 12, 13, 14, 15. So there are a total of 15 lines plus the 1 championship game, which would give you 16. Obviously, this would be a lot easier to draw out on a piece of paper versus a computer screen, and use colored pencils if you want to see it. So it's kind of actually seeing the combinations in color and played out in visual, as far as player 1 can play all of these people, player 4 can play these people now, and just not repeating the same thing over and over again. So that's another example for you. Looking at one last example, because this is something else that you guys will see since we've been talking about probability. So using the same scenario, it says if the players are selected at random, what is the probability that player 3 will play player 6 in the first game? So in this, the answer is already here for you guys, but just to explain this a little bit, it says there are 15 possible first games. So that's kind of what I already figured out in the following slides, that there are 15 games. The last game, the 16th game, was the championship, so we're not counting that in this. And there's only 1 favorable outcome that this will happen. So there's only really 1 chance that player 3 is going to play player 6 out of those 15 games. So your probability is 1 out of 15. Remember that it's always written as a fraction. A probability is not just writing a number or a percentage, it's writing 1 out of, that's what the slash or the fraction represents, is that's 1 out of 15 possible outcomes that can happen. Okay. And just one last example for you to think about, and this is, I know you don't have a sheet for this, but this is one of the questions off of the sheet that you would have had. So it says, in how many ways can you pick 2 stickers from a pack of 7? So there are 2 stickers and you're only picking 2 of them. So using that one method, it was method 2 from one of the first slides. So the entire set, I have 7 stickers to pick from. After I've picked one of them, I now have 6. So the entire set that I have would be 42. So I have 42 since I'm only picking 2 stickers. That's why it's not continuing to multiply by 5, by 4, by 3, by 2, by 1. Then I have my smaller set, which is the amount of stickers. So I have 2 stickers that I'm picking. So I have 2 times 1 is 2. And then I'm going to divide 42 by 2 to get 21. So it's showing you that the number of ways you can pick 2 stickers is 21. You can do the same thing if you want to put 7 little dots and say sticker 1, sticker 2, sticker 3. You can do that if you want to label the stickers and do the letters and then go back and cross them out. You can do the same thing. This way is probably the fastest to do. If you guys have questions, please let me know. I will be more than happy to answer them. Sorry about the lines in the other video and it taking a little bit longer to get through. But I hope you guys have a great day and have a great week before spring break. Bye, guys.